Hey folks, welcome to another ND update video. We'll be going through some of the new features in version 1.47. You'll also get a glimpse into the future of ND. Let's get started. The first new operator we'll look at is edge length. This operator allows you to precisely set the absolute length of one or more edges or offset their current length by some amount. To use, you'll need to be in edit mode. We'll start with one edge as an example. With the edge selected, open the sketch menu and choose Edge Length. Let's break down what we see here. First, moving the mouse left and right will adjust the distance parameter. An edge comprises two vertices, so its length is the distance between them. You can see which vertices are being adjusted via the green dots displayed in the overlay. By default, the start and the end vertex belonging to the selected edges will be moved equally in opposite directions along the path created by the edge. This is dictated by the selected anchor type currently set to center. You can choose alternative anchor types by hitting the A key. The options are start, end, and center. You can always visualize where the anchor point lies by looking for the orange dot. The last option is the distance type. When a single edge is selected, it will default to absolute. This means that whatever the distance is set to will be the final absolute length of the edge. This is great for when you're looking to precisely set the length of an edge. You could be modeling a product with strict measurement requirements, creating an object that will be 3D printed, etc. While the distance option is absolute, the smallest distance you can set is 0. Anything below 0 makes 0 sense when talking about the length of an edge. The second distance option is offset. This works by adding or subtracting the distance value from the original length of the edge. In this case, going negative is valid and, hence, can result in you creating intersecting geometry if you push it a bit too far. This option isn't as valuable as absolute for a single edge, but it makes more sense for multiple edges. So let's take a look at that example next. I'll first set this edge to a length greater than what it started at. Let's commit to that change. Now I'll select two edges. But before I do, it's worth noting that this operator only works with multi-edge selection if all the edges you selected are disconnected. You'll get an error if they're connected, as seen here. This is because connected edges share vertices, and it's impossible to move a single vertex in two different directions simultaneously. Unless we dive into quantum physics, but that's for advanced ND. We'll stick to regular ND here. Okay, let's select two disconnected edges and run the operator. Here you'll see a similar setup, except that we see multiple vertex and anchor dots, and the distance mode has been set to offset. However, the behavior is still the same, so adjusting the distance here offsets each edge's length by the specified distance. Hopefully you can see why offset mode is more valuable in this situation. However, absolute is still an option if you want to ensure that all selected edges are set to the exact same length. Now, things may get strange when the anchor is set to start or end. If we try that now, you'll notice that the anchor points for each edge are in different locations, causing the active vertices to move in opposite directions. The reason is that each edge's vertices are wound in a particular order, and from a pure code perspective, it's not easy to determine which of the vertices should be considered the start or end points, especially so in more complicated selections. We're obviously only looking at a simple two-edge selection here. Luckily, there's an easy enough solution, hinting at the operator what it should consider as the starting point. We can do that by placing the 3D cursor where we want the starting vertex selections to gravitate towards. So, for example, if I hold down Shift and right-click near the side of the cube and then rerun the operator, you'll notice that the anchors behave more intuitively. Before we move on, I'd like to thank Shadow, who contributed the groundwork for this new operator. If you didn't already know, ND is a free and open source add-on. So if you're a Python developer with Blender API experience and would like to contribute new features to ND, enhance existing features, or help fix bugs, please get in touch. The best option is to join our Discord server, chat there, or check out the GitHub repo. I'll leave a link in the video description. Okay, let's check out another new set of operators. We've been planning to integrate geometry nodes more deeply with ND for quite some time now, as proceduralism and non-destructive work so naturally together. So I'm excited to showcase the first two GN-powered operators added to ND. You'll find these two under the new Generators menu, which can also be accessed by the dedicated shortcut Shift-Alt-G. I'll quickly reset my scene, and then we'll look at the first operator, Hole Generator. The Hole Generator does what it sounds like, generates holes. It works in two context modes. The first is when you don't have anything selected, and the second is when you do have something selected. Let's go with the second context, as is 99% of the time how you'll end up using it. Now, like other operators such as Recon Poly, the Hole Generator spawns the hole object at the location of the 3D cursor. So given this cube, I'll set the 3D cursor aligned to the top face before running the operator. Now that I've marked the position of the hole with the 3D cursor, let's run the operator. I'll ensure I have the cube selected before doing that though. You'll notice that the Hole Generator operator has created a new utility object and automatically performed a difference boolean with the selected object as the target. The first parameter we can adjust is the hole diameter. The second is how many segments you want it to have. We'll return to this later to show you what happens occasionally with the underlying boolean operation. The third is how deep you want the hole to be. Now, in its most basic form, you can treat it as a non-destructive cylinder generator with a small protrusion at the top to facilitate Boolean operations. However, there's much more. We have various configuration modes at the bottom of the overlay: hole, counter, and drill. Let's press C once to switch to the counter configuration mode. Here we have an option to choose the hole type. We currently have simple selected. By pressing H once, we can switch from simple to counter bore. This generates a counterbored hole with a configurable counter diameter and depth. Super neat, huh? There is a reset automation option here that, when pressed, will automatically set the counterbore diameter and depth based on the hole's diameter and depth. It might not work for everyone though, so you still have the option to manually set the parameters. Once you alter one of the parameters, the auto suffix will disappear and automation will be disabled. Following this, if we hit H again, we'll change from counterbore to countersink. Here you can set the diameter and the angle of the countersink, which is set to 45 degrees by default. The last configuration mode we have is drill. Here you can select the drill point type and set it to flat or angle. In angle mode, you can adjust the angle as required. Let's commit to that and take a quick look at the result. The Hole Generator is excellent for all sorts of details and engineered parts. While it isn't a feature yet, we may extend this generator or add a complementary one to generate matching screws and bolts of various types with optional threading. As with most things in ND, the Hole Generator object can always be selected again and the operator recalled to adjust various parameters. It's wholly non-destructive and procedural thanks to geometry nodes. If you look at the modifier stack, you'll see the Hole Generator modifier. Here you can access all of the parameters if you prefer adjusting them from this interface or want to perform more advanced actions, such as connecting any of the parameters with drivers, etc. Here we also have a couple of extra parameters not exposed via the ND overlay, such as the protrusion distance and the vertex merge distance. They're there for more unique cases, such as when you're creating very small holes and the default merge distance of 0.1 mm or whatever equivalent unit type you have Blender set to is too big. The protrusion distance here adjusts for how far the Hole Generator object protrudes from its origin point and is mostly in place to support the fast Boolean operator's quirks. While on the topic of Booleans, it's worth mentioning that it's something to watch out for. If you ever change the segment count on the whole object and notice that the Boolean is failing, as you can see here, it's probably due to the fact that Blender's fast Boolean algorithm doesn't always work well in these situations. You can solve this, however, by going to the target object and swapping the solver to exact. Remember that the exact solver is more computationally expensive, and using many of them can slow down Blender. Okay, that's a wrap on the Hole Generator. Let's look at our other new operator, the Pipe Generator. I'll clean up the scene and jump into the front orthographic view. Here I'll add a single vertex and then extrude it a few times to form an edge path. Now back in object mode, and with this new edge path selected, let's run the Pipe Generator. Here, a basic pipe shape has been generated along the edge. We have several options here, so let's look at them. First is the profile radius. This is how thick the pipe is. Then there's the number of segments. You can go down to 3 in this case, or up to as many as you need to get the results you're after. Next is the base corner radius, which determines the amount of curvature added to the corners of the pipe. You can also choose how many segments the corners should have. So, using those 4 parameters, you can quickly generate a basic pipe object from a simple edge path. Next, if we look at the pipe's ends, we'll see that they're closed or capped by default. You can turn this off by pressing F and changing the fill caps option to no. You can press F again if you want them back. If you're already impressed and expected this to end here, buckle up, it'll get even more crazy. Similar to the hole generator, we have several different configuration modes here. Let's take a look at the second configuration mode, corners. In corner configuration mode, you can cycle through the corners of the pipe and adjust their individual settings. For instance, you might want one corner to have a smaller or larger radius than the others. You'll notice, however, that if you set either the radius or segment count to 0, it will resort back to using the base radius or segment count defined in the generic pipe settings section. The base prefix will be shown if this is the case. If you've changed any settings and don't like them or want to restart, you can hit R to reset the corner back to the base settings. Or if you've adjusted multiple corners and want to reset all of them, hit the A key. Let's take a look at the following configuration mode, ends. In this mode, we can cycle through several different built-in end connectors, which can also be rotated if necessary. Suppose you wanted to get more specific with the connectors. In that case, you can press S to unsynchronize them, allowing you to choose a unique connector for the start and end of the pipe, each with its own individual rotation if necessary. If you want to return to synchronized connectors, press S again. You can also reset the connectors by pressing R. Now, you're probably wondering if you're limited to the built-in connectors, and the answer is no. We've thought of that option as well. I'll select the simple connector for this pipe to demonstrate how they work and then commit my changes. If we jump over to the modifiers panel and look at the pipe generator, you'll see that the start and end connectors can be specified by selecting a collection. But where are these collections coming from? When ND is active and you load up a new Blender scene, it'll automatically inject the built-in connectors into it. You can find them by going to the outliner and switching from View Layer to Blender File. Then look for the Collections category and expand it. Under here, there is an nd.connectors collection. If you right-click on it, choose Link to Scene, then switch back to the View layer, you'll see it now exists here as well. If we zoom out in the scene, we can see all the connectors displayed. I'll now select all of the connectors except the simple one and unlink them again, as I only need the simple one for this demonstration. I'll select it in the scene and move it off to the side so we can see it and our pipe simultaneously. A connector must follow some rules to work with a pipe generator. The first is that its origin point should be at the bottom of the connector, or instead, the part of the connector that would be up against the object the pipe is connected to, let's say a wall, for instance. The second rule is that the opening of the connector needs to be precisely 1 unit in diameter. In Blender, this would equal 1 meter as it works in meters under the hood. If your units aren't set to meters, you'll need to make the appropriate conversion. For instance, I work in millimeters, so the opening of the connector is precisely 1000 millimeters. If the details of the connector extend past that point, it's perfectly okay. The last rule is that the connectors need to be in their own collection and a part of the parent nd.connectors collection for them to be discovered by the pipe generator overlay. However, they don't need to be in the ND connectors collection if you don't care about that and want to select them directly via the modifier's parameters. So, from here, let's make a few changes to the simple connector. I'll jump into edit mode. As you can see, this connector is just an edge profile that has been screwed around the z-axis 360 degrees. This makes it very easy to edit and non-destructive. I might subdivide this long edge and extrude it outwards, fixing up the geometry as I add a ring around the outside of the connector. If we look at our generated pipe, you can see that the connector has also been updated there. The other neat thing about the connectors, when they follow the rules I outlined, is that they scale gracefully with the pipe when you change its profile radius. This ensures the proportions always look correct. The incredible thing about this is that it's all still driven by a straightforward edge path. Making changes is extremely easy and satisfying. It also works in all 3 dimensions, so you're not limited to flat profile edges. Now, there are a couple of caveats to keep in mind. First, this operator doesn't work with edge paths that diverge or split. We'd like to extend the functionality in the future to support this and introduce split corner connectors. The second caveat is that connectors won't work as expected if your edge forms a complete loop. However, the rest of the pipe generator still works. This can generate some additional interesting shapes. For instance, if I add in a plane and then delete the face, leaving just the edges behind, then run the pipe operator on this, you can create a non-destructive torus. Or, if I go back to a more rounded square shape and set the segment count down to 3, we will end up with another interesting detail piece. The pipe generator can be hacked like this in various ways. Finally, like the hole generator, the pipe generator has parameters that aren't exposed to the overlay, namely the vertex merge distance. This one is important to note, as you may sometimes encounter weird shading if your profile radius and corner radius collide. If that happens, playing with the vertex merge distance is probably the first thing to try. Alright folks, this video has gone on long enough. If you want to see the other minor changes in the version, please check out the changelog. As always, I hope you enjoy these new features and the future of ND. It's full of geometry nodes goodness. Leave a comment on this video and tell me what you think of these new operators, if you have ideas for more, or if you would like to contribute towards ND. I'll see you next time.